I suppose I don't have anything administrative to say. I did want to, excuse me, I did want to take a minute and talk about Packback, which I really should have done on Thursday, but I kind of forgot I needed to because I've been planning to talk about it on Tuesday. But then, everything kind of went away with the cold. So anyway, I'm going to do a quick walkthrough through Packback so you can see what it's all about for those of you who haven't tried. Okay, so there is an instructions document here. It's pretty similar to what I covered, in the announcement that went on Blackboard. So just to do a recap of that, right? Basically, Packback is online Q&A. Over the course of the semester, you can get 200 points, right? There's that 200-point share of the 500 points in Blackboard. At the end of semester last year, I got some strange emails from people who thought it was extra credit. It's not extra credit, okay? So not extra credit. And people always ask, do we have to do it? And I say, well, I'm not going to make people do it, but you don't get the points for it if you do it. So sure, okay, you have to do it. Anyway, so you can get up to 200 points through the semester. Each week, you can earn up to 20 points. So since you can participate each week, and there are more than 10 weeks, you can get that 200-point semester cap before the end of the semester. There's no special bonus for going over, right? If there's a conversation you're interested in, by all means join, but 200 points is the semester cap. Okay, way it works, each week you can get credit for up to 2 questions at 5 points each, and up to 4 answers at 2.5 points each. Want to keep that 2-to-1 ratio, right? Because it's not good to have a bunch of questions and no answers. So that's why it's set up the way it is, so that we get conversations. So on average, each question should get about 2 answers. Each answer and response has to be evaluated by Packback as scoring at least 50. So what they call it is a curiosity score, because the idea is it's supposed to stimulate curiosity and learning, whatever. Basically, they have an AI platform that looks at your grammar, looks at your writing, looks at whether you include a link, and if the link appears to be related to the topic of your post. Honestly, the AI isn't great. If you really want to fool it, you can fool it, but this is one of those things in life that you get out of it what you put into it. So if you want to have some interesting conversations, develop some knowledge about various IT or other business topics, the way to do it is to actually, play the game the way it's supposed to be played. Okay. The other thing about the Packback scoring, it considers questions to be good if they're open-ended, right? It doesn't want ones that just lead to a simple fact, end of discussion, right? Like, what were Facebook's 2024 revenues? And somebody looks it up and it's like 120 billion. Boom. There's no conversation there. It's just done. Okay. So Packback doesn't want questions like that. Packback wants ones without a clear, correct answer. Okay. And the deadline for each week is 11:59 Friday, Chicago time. Okay. Occasionally things go, with Packback, if you don't score well on your question or answer, you can revise and resubmit it, right? It's not like an attempt that completely failed and you've lost the opportunity. If you score a little low, you can rewrite it and resubmit it. It's pretty easy to do. So, deadline for each week is the end of Friday. Don't wait until the very end of Friday. Don't be one of those sad people who, tries to send me an email. Oh, I started at 11:55 p.m. and it didn't like my question. By the time I revised it, it was 12:03. Okay, because there's already a lot of flexibility built into the assignments, right? Where you can totally skip weeks. It's available during spring break. I'm not going to be flexible on deadlines because I don't want to go in there and dig around in Packback for each individual person to track what they're doing. It's just, if you miss a week, you miss a week. Life goes on. Get it next week. Okay? Because you can already skip 5 weeks. The other caveat, I got emails from a few people who were probably salty at the end of the semester. Basically, they didn't do Packback all semester. And they said, hey, can you open up all the assignments for me in the last week? And I'm like, no. I mean, yeah, I could, but no, what kind of lesson would that do? That you just fuck off for 15 weeks and then at the end, oh yeah, gotcha. All right. Okay, so not going to do that either. just to set everybody's expectations, right? Deadlines are strict. And when I say deadlines are strict, I mean, I'm not going to change stuff. You can already skip weeks. Yes. Yes, the code is just the professor's name, right? So I'm going to demo that in just a second. So I have this section. I'm helping out two instructors who are new to the course. So you have the option of Lundquist, which is me, or Westland, which is another professor, or Choi, who is another professor. But, you know, when you pick your section in Packback, you want to pick the Lundquist section because that's presumably the one you're in. Okay. So let's do a demo. If you want to go to Packback, right, you can click this link. And I haven't actually had to register for it as a student and pay for it. So I'm not exactly sure how that works. But I will say they've probably made it really easy for you to find where to give them your money. Just saying. Okay. So this is me. Let's make a, let's do a, you want to look at assignments once you get in. All right. So Packback number 2 is open. So I'm going to make a question for that one. All right. You see how it works. So do the topic here, ask a new question. Now, as far as new questions, what the topic should be is something related to what we're covering in class, right? So right now we're covering Facebook. In particular, we're covering the feed. So there's a lot of stuff you could work with there, but basically it's Facebook. So anything social media is fine. And it doesn't have to be an IT issue. It can be something related to business, right? It can be any aspect of their business. It could, well, today we'll talk a little bit about newsfeed and the recent changes in some of Facebook's policies. We'll talk about it. So anything like that, as long as it's related to Facebook, ideally related to the feed, but any, you know, any social media Facebook kind of topic is fine for now. When we go on to Amazon, basically anything with Amazon, anything with online retailing, anything as far as specific topics we do. For example, I believe we start off with transaction processing. So if, or I think transaction processing, then cloud, then recommender systems, or maybe it's the other way around. I haven't looked at it in a while. Okay, but whatever topic we're doing with Amazon, any of those would be fine as well. Okay, so what am I curious about? Well, lately there's been a trend on Facebook with, you know, since the election for more free speech, right? Basically less censoring. They've gone from having outside operations look at people's posts and evaluate whether they should be repeated or not, or made visible or blocked, whatever. And now they're saying, okay, we're going to have community notes. So regardless of, you know, whether your opinion on that is happy or sad or indifferent, you know, you can still make a question about this, right? So let's say recently Facebook has lifted some restrictions on posting and replaced monitoring with, what's the word I'm looking for? Community notes. Will this harm Facebook in the long run? Okay, that's a pretty open-ended question, right? So we're going to add a description down here. So let's say here, Facebook until recently had been monitoring and blocking, let's say user posts on controversial topics. Okay. Perhaps, let's say, probably in an effort to avoid, what's the word I'm looking for? Excessive federal scrutiny, Facebook has updated its policies to a more free speech orientation. Okay. Will this harm Facebook's financial prospects by driving away more users than it retains. Okay? By more users than it, I don't know, brings back. How about that? Okay, and then the last bit, so come up with a question. And the last bit, we're going to go on Google and we're going to find some article about this. All right, so Facebook new community notes 2025. All right, here we go. We're just going to grab that. What is community notes? How will it work? Okay, so you can read the article if you want, but I'm like just zipping through. So I'm going to include a link. So add a source, source website, Okay, click search. It will go find it that this page isn't just a URL that I made up. I save and close. All right, and we submit. Let's see what they think. Submit it now. Yeah. What does it score at? And it scores a 64, which is good enough for credit, right? That little number there, if we hover next to it, curiosity points, that's basically says, okay, yeah, this is good enough, right? So the bar for jumping over a 50 is not that big, right? Just take it kind of seriously and you should have no trouble hitting 50. And if you do have trouble hitting 50, you can always edit and resubmit, okay? All right. So that's Packback. Questions? All right. And if you do have questions later, like I said, remember, up here on Blackboard, there is this Packback instructions document. Although I guess the way that life is probably the people who ask me the questions about it are the ones who aren't here to hear me say, yeah, there's this document. Okay. So there's that. Any questions? Going once? Going twice? Gone. Okay. All right. Well, then we're going to fire up iClicker. I know people are wondering, hey, what's this iClicker thing? Let's do that. Okay, so we're going to fire up iClicker. And we are going to start our session. Okay. And I'm going to ask a question today. Okay, so we're going to do a poll. The question will be, do you think Facebook's new, let's say, moderation approach will A, harm Facebook financially, B, help Facebook financially, or C, not change much either way? Okay. And let's go. So it has been launched. So I'll give you a minute to think about it. All right. Doing our countdown. I'll give you 5 seconds for those of you who haven't joined in yet. Do, 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 do. Do, 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 do. All right. So for people who do not get to iClicker in time, you're having troubles, whatever, give me a shout in class. Is there anybody who's having iClicker troubles? You are having, yes? Okay. So What's your name? Okay. Please send me an email right now during lecture, and then you can, there'll be a record of what happened. Okay. That's cool. All right. So hopefully anybody else. So in general, when we're doing these iClicker things, if you're having a problem, let me know during that moment. All right. If you find me after class and you'd be like, hey, professor, I missed question number one. I'll say, well, I don't know if you just walked in half an hour late. I'm not watching the class that closely. And there's a lot of you. And yeah. So gotta mention it in the minute, right? Same thing. I occasionally get students like a couple weeks afterward. They're like, oh yeah, I missed a question. I'm like, how am I supposed to know that now? Right? How am I supposed to verify? Yeah. Yeah, same thing. If, you guys have probably figured out that I'm not extremely formal, right? If you have a problem, it's okay. You can say, hey, Doug, iClicker trouble. And I'll be like, yeah, okay. Okay. So if you're having trouble, I need to know. All right. Anything else? Shall we move on? All right, let's move on. Okay, good. That's all right. I like it when people are not afraid to speak about class-related topics. Okay. Good, good, good. So where we left off was talking about the feed. Dun, dun, dun. We had all this stuff like basically, here's what Facebook does, right? It tries to pick posts that are likely to be interesting to the user, and it arranges them so its best guess about what's most interesting is at the top. And hopefully that keeps people staying on Facebook longer, keeps them interacting more, seeing more ads, clicking on more ads, right? Okay, so that's what we all talked about. And then we talked about different ways where Facebook tries to figure out what's interesting. One option would be to have you fill out a long series of forms about topics you're interested in. But the better approach, if you have time to do it, is to actually track the kind of things that users click on, that users interact with, and show you stuff like that. And so that's mostly what Facebook does. All right. Other things, we just have some related topics, presentation issues. So one other thing, besides just the kind of content, even the way something is presented could be significant in terms of whether users interact with it or not, right? So if you have a mobile device, right, obviously it has a different orientation. It's more what's called portrait, more up and down, versus a desktop, laptop, whatever orientation, more landscape, more side to side. Okay. Desktops in general have bigger screens, so you can show more ads. You can have your little bit of Facebook content in the middle with ads all around it. Mobile devices, you're not going to see that the same way. So you can get the same number of ads to a desktop user, in the feed, but then you can add extra ones along the edge that hopefully are more useful. Anyway, and some things that are easy to use in a desktop are not at all easy to use on a mobile device. Some of the early games that were great for mobile devices, things like Angry Birds, Candy Crush, stuff like that, they got really popular because they were a great thing to do for a few minutes while you're waiting for a bus or waiting for a restaurant meal, stuff like that. Okay, when people just had these little moments of time. Desktop, it's a little different experience. Okay. Skip this. I mean, it's the same idea, though. In a lot of cases, you're going to want to design your content so it automatically scales with the viewing area, what's called the viewport. So ads, you get the idea. Oh, clickbait. Clickbait's always fun, though. Okay. So clickbait, of course, there's a lot of it. It wouldn't be a Facebook feed without clickbait, although lately there's less of it than there used to be. So what's the distinction between ordinary clickbait and, just a post of questionable quality? Well, I'll talk about that. So, first of all, what makes clickbait its own thing? Number one, it's bait, right? Bait means luring you into it. So it has to be more enticing than the information probably is, right? There's a variety of ways to do it, whether, overly sensational or outright misleading, right? Any of those things could be it, but that's what clickbait is. Number two, right? For some reason, the producers want clicks, right? Maybe it's an ad of some kind, or maybe their website will make money off the traffic. Okay. For example, through ads embedded in it. So, classic example, right? Something like 12 signs your girlfriend is about to leave you. You won't believe number 7, right? Stuff like that. We've seen it. Or, 100 places you must visit before you die. You won't believe number 7, right? Anyway, so some of these, again, I'm not going to put myself in the position of deciding which content is of value or not, right? This first one might be entertaining, might even be useful. Second one might be entertaining, might even be useful. But definitely they're like trying to say, oh yeah, you got to come check this out, right now. Other things, like how to make money by trading options, right? It's safer than you think. Hint, it isn't. Anyway, so that's the idea with clickbait, and there's a bunch of it. But how do they make money? Well, in general, same as any other online ad. Sometimes it sends you to a place to buy products, right? So, for example, right, this one, the 12 signs your girlfriend is about to leave you, maybe the author of the post is selling relationship advice books or subscriptions, right? Maybe that's how he's making money. So even though it doesn't feel like an ad, by the time you get to the end of it, it says something like, well, now that you know the 12 signs, you should buy my book because blah, 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 right? You wouldn't be here if you weren't concerned. Or this one, right? Maybe the site links to hotel and airline and cruise sites, right? Businesses. So, and they get a cut from referrals. So, a lot of time it's decent, or, again, make lots of money at home trading options, right? This one, probably an outright scam as far as risk, right? I mean, obviously, you guys have seen the infomercials at night, right? Trading options. Yeah. Some people do make money doing it, right? So it's not that you couldn't. And some people surely must make a lot of money doing it. Not very many, but some. But if they tell you, yeah, this is anybody who's a finance major, you're going to learn more about options and you'll see why this is a crazy thing, right? But if they tell you there's not much risk or that they can somehow do away with the risk and you still make money, that's, the FTC will probably eventually catch up with them. Okay. Anyway, so that's clickbait. Next stuff is technical system things, but I could kind of push this off till Thursday. So what I wanted to do today, I had usually I don't go talking about current events too much, but it occurred to me we're in the topic of Facebook feed, and there have just been some really big practical changes to Facebook's feed. We could talk about that, but I don't want to talk about it in terms of, whether it's good or bad. I want to talk about it in terms of money, okay? Because if we talk about good or bad, things can get contentious. And I figure if people want to get contentious, they can do that on their own time, right? But let's talk about, will Facebook's, financial situation improve or not from the recent feed changes? Okay, so let's think about this in concrete, specific terms. Basically, Facebook has money coming in. I'm going to draw a big arrow there. And they also have, that's a pretty shitty arrow. Let's, I can do better. Look at this. This is a good arrow. All right. Beautiful. Look out, Disney. Okay. And in the middle, we have Facebook. Good enough. All right. So how does money get into Facebook, right? Mostly from ads. Okay. And how is Facebook going to be losing money? Well, basically two things, right? If users leave or advertisers leave. Okay, that's pretty. Oh, there's a third one. There's a third one, right? What if government, well, let's say legislative action. Okay. Some kind of legislative action might interfere with Facebook's business model. Okay. So what do you think about any of these and any changes that might happen, might be on the horizon? Cash coming in and cash going out. What do you think? Well, let's put some numbers on it. Let's say ads are about 120 billion a year. Okay. Now, do you think advertisers are going to be happy about the changes, unhappy, fairly indifferent? Yeah. Oh, I thought I saw a hand up. What do you think? Well, advertisers want to reach users, right? Do you think there are going to be more users on Facebook or fewer? Do you think a lot of people will leave that are already on? Do you think some people will come back? What do you think? What's that? Okay. Well, I'm sure there'll be some of both, right? But I guess it's the question, net effect. You think more people will leave? Okay. Well, let's do an iClicker thing around this. Let's see what people think. Let's stop that one. Huh. Guess a few people did join in at the end. Okay. So let's do this. What do you think will be the net effect on user population? Okay. And I'll say here, we'll go from, well, we start off with negative, so we'll go with negative. We'll say drop by 10%, drop by 5%, drop stable, up by 5%, and E up by 10%. Okay. We're going to see what people think, and we're going to add up the numbers. And we're going to figure out that with the wisdom of the herd, we're actually getting something accurate. All right. Give about 10 more seconds. We're going to wind this down in a minute. What's that? Okay. Okay. Send me an email. What's your name? Okay. That's good. Okay. Yeah. Okay. We're shutting it down then. Ding, ding, ding. Okay. And boom. Okay. Let's see what people said. Interesting. So the net consensus is a little bit of a drop. Let's do this. We're gonna say this balances out, this balances out. So there's about a 30% excess at 0.5, right? So let's say the consensus appears to be it's gonna drop by a couple percent. Okay, so this stuff is all even. 30% at -5. So let's say drop by 2%. That's going to be what the number is. Okay. So consensus says small drop around 2%. Okay, you have spoken. So let's look at what that means in terms of advertising. Okay. Well, in terms of advertising, let's say about 2% of 120 billion, let's say about 2.4 billion from users leaving. Okay. So if users leave, all those are users who can't click on ads. And we might reasonably assume that the users who leave have similar ad clicking behavior than users who stay. Right. So we're going to put that as a cost 2.4 billion. Okay. Advertisers, well, even if some advertisers leave, there'll probably be enough there for Facebook to show to everybody. But let's go along with that and say that if the number of people leaving goes down a little bit, it's probably likely that advertisers have a similar negative effect, but it's going to be smaller, because maybe you won't have the best advertiser for the best product at that point. And it's also fair to say that the advertisers who are leaving are probably demographically targeting the users that are leaving. But let's say they drop a little bit there, right? Less, but something. So let's say like another billion there is maybe a defensible number. Okay. But now we have to consider the cost of legislative action. Okay. So suppose the feds, under their new government, they look at Facebook and say, you know what, Facebook, you guys, you're in a lot of trouble, and we are going to really run you through the ringer to make sure that, you're not doing these things we don't like you to do. So that's the follow-up question. Follow-up question is this. I'm going to do another poll for this one. This will be the last one for the day. I'm going to do it right now. Okay. And I'm going to say the numbers are probably going to be bigger, but let's consider. What would be the net effect of probable legislative actions against Facebook if they retained their old post moderation policy? Okay. And I'm gonna double up the numbers. So it's legislative action. So there's no way Facebook is coming out of this a winner. But I'm gonna say 25%. Yeah, 25, 20, drop by 15, drop by 10%. And I'll leave a spot for nothing significant. Okay, and I'll put in last here, drop by 5%. Okay, so we got this. Let's see what people say. Well, wait. I want to do this the right way. I'm not sure how it's going to react to. I've never done a 6-point, but let's see if it handles it. All right. Do you guys get an F option there, or does it only go up to 5? Yeah, I didn't think so. Okay, fine. Just skip F, go with these. If anybody really thinks, nothing significant, then. But it seems likely that, it would be anywhere from an inconvenience to a great inconvenience. Gonna be something there. All right. Tell you what I'll do. I'll split that 5% category. Half of those I'll make zeros. Then I'll get the zeros in there somehow. So probably some people who are picking 5%, they would have picked zero. So I'm going to guess about half. We'll see. Probable. Probable. All right. All right. Going to wind this down in a minute. Okay. All right. Let's see. Let's take a look. Yeah. Oh, look at that. Again in the middle. And let's say if I split that, it's probably about 50-50. So not many people are thinking it's 25%. There seems to be a little bit of a tilt towards this, towards like 15 or 10%. So the average, let's say, yeah, let's say about, I don't know. I'll even go low. I'll say like 10%. Okay. So legislative action though, cost, well, let's say something around the order of 12 billion, right? So this is probably pretty accurate as far as what Facebook assessed, right? Facebook probably said, yeah, there's going to be some users that this isn't popular with. It's going to cost us maybe a few advertisers too, and there's going to be some mismatches between the advertisers that we keep and the users that we keep. You know, the advertising isn't going to be as good. It won't be, you know, dramatically bad, but it's worth it to avoid that big legislative action thing, right? You know, the feds might be looking at Facebook and saying, you know, we got to do something about this. We got to, you know, I don't know. So we'll see. I'm pretty sure something like this is about what they were thinking, that they wanted to avoid that problem. And if the cost was users leaving and some advertising, well, it was a smaller cost. So, all right. I don't know. Any thoughts on that? Any counterpoints? Because I'm not a Facebook expert in this regard. I'm just saying this seems about right to me, but I don't know. Maybe. Okay. All right then. Well, good discussion. Okay. Chatty bunch. All right, let's see what we got here then. Let's go back. All right, so the rest of this, some technical stuff, right? Content management systems, talk a little bit about the cloud, talk about some other things. Okay, so first of all, you can ask, what is a content management system? Well, if you're Facebook and you're really big, just maintaining a really big database is all by itself a big challenge. You have to make sure it's available all the time. You have to make sure that it's fast to find what you're looking for in that database. You know, you have to ensure that you have space to grow, you know, but the fact that Facebook's data is very dynamic, that data might be popular one day and forgotten the next day, right, makes this all much more complicated to manage. So first of all, at Facebook, there's a continuous flow of new, most recent data. All the time, around the clock, people worldwide are making Facebook posts, and those posts are briefly going to be cached in RAM before they get, you know, kind of forgotten and get moved to permanent storage, and some other newer content goes into RAM, right? So there's that continuous flow of new, most recent data. And Facebook does a whole bunch of stuff in real time, right? Like 15 years ago, if somebody, you know, liked your post or sent you a message, you had to refresh the page in order to see that, right? And then when they started showing all this stuff in real time as it happened, well, that was a big change. I'm not going to swear to being exactly 15 years ago, but it was about 15. Uh, And of course, people are perpetually making small changes in access and friendship, mostly to add new friends, but occasionally to block old ones, right? And people are deleting accounts and creating new accounts and all that. So there's a lot of content that has to be managed. There's a lot of issues as far as maintaining continuous, reliable access to that content. Okay. Now, one of the big problems that Facebook had to deal with early on is that what happens if there's some content that's super popular and a bunch of people want it at the same time? Okay, so we'll talk about that briefly. Okay, so we're going to draw a disk drive. Okay, so here's your disk. Now, suppose you have a bunch of users who, at the same time, are all putting in requests for this particular thing, right? So suppose you have a video and it's only, well, you could say an image, a photo stored on one disk, and there are many requests for it. Okay. Well, problem with old-timey disks, about the maximum speed you are ever going to get is maximum capacity was about 40 reads per second, right? Or 40 downloads per second. And part of that is the fact that it takes, a little bit of time to actually read the data off the drive. And part of it is the fact that you need to spin the disk around, and that takes time to figure out where you got to start. So maximum capacity for a system like that was about, 40 downloads per second. I don't know what happened to that 40 there. Okay, so 40 downloads per second, though, is not actually that much in the big scheme of things, right? So if you have, let's say, what does that turn out to? There's 86,400 seconds in a day. So that means, rough numbers, you could get about 3.5 million requests per day. But because that's the cap, something that's popular, something that's a popular news item, or what was going on in 2010, I don't know, maybe Rihanna or Katy Perry had a new song, something, and a lot of people go on Facebook to see it, that's going to be a big problem. That's like one disk that's the only thing that can hold, and you're going to need a bunch of different copies of it, right? This sort of thing was a big problem for Facebook early on. So very popular data, it wasn't easy to manage the access to it, right? So that massive number of repeated access requests could overload the system, especially if they were all processed by a single data center with only a few copies of the data. Okay, so part of the solution to that, number one, is put popular content in fast RAM. So since RAM is very, very fast, it can service a lot of those requests a lot faster. Second thing, various kinds of replication. So not only do you make multiple copies of something at the same data center and keep track of, as demand is starting to go down, then you add on new copies of something else, but you also copy those chunks of video around the world to prevent that kind of bottleneck, right? So if we're talking here just about one picture, yeah, there's not going to be that many pictures in the world that create this kind of problem. But imagine, Facebook used to do these big global promotions, and probably hundreds of millions of people signed in at just about the same interval. So imagine if you're doing something live, right? Like, I don't know, Taylor Swift confesses to a murder on Facebook, and, a billion people tune in. If you were doing that on that old kind of system, you would need a lot of devices, right? Basically, for the amount of staggering you'd have to do, you'd have to add in like literally millions of hard drives just to deliver that kind of content. So doing those kind of big live things was going to be a very difficult thing to do without some special modifications to their system. All right. So this is, if you're interested, this is kind of old stuff though, but how they do live broadcasting video to millions, you know, they required some advanced special solutions for that. Okay. Now, technical elements about the cloud, right? So here we get a little bit of an intro into the cloud. We'll build more on it in the Amazon module, but talk about what cloud is. So Facebook has way too much data to store on one single machine, right? They have simultaneous connections for millions of users, right? Possibly hundreds of millions of users at any given time. Massive read-write requirements. Some users are going to be downloading stuff from Facebook. Others are going to be uploading stuff. And it needs to be always reliable. So anything you have has to have multiple backup copies in place. So the solution to this is what's called a cloud system. And in a cloud system, what happens? Number one, all the operational requirements, all the things that the system needs to do, you break them up into pieces and allocate those pieces to run separately on different machines. And part two, the cloud details are hidden from users, part for security, part for ease of use. Okay, so the old example you always used to see in books about this kind of hiding the details was the microwave, right? Microwave, most people don't know how a microwave works, right? There's probably a few people in here who have some idea beyond, well, there's radiation and it hits the food and the food gets warm, right? There's probably a few people that could talk about like the specific mechanics of microwaves as opposed to other frequencies. But mostly, you don't need to know too much about that. You know, you put the popcorn in, you press the popcorn button, 3 minutes later, you have a bag of cooked popcorn. Okay, so same kind of thing with cloud. All those details about what machines your files are on and the network connections you get to them, you don't need to worry about any of that. You just go to the interface facebook.com, tell them your account information, and Facebook brings the stuff to you. You don't need to know any of those back-end details. Okay, so what is a cloud? It's a server network, so a bunch of different servers all working together with, number one, a shared interface. That's the point where the users reach the system. Number two, load balancing. Number three, backups. We'll talk about that. Other typical features, cloud systems tend to be not just in one place, right? So when you go to Facebook, the information you're getting could actually be from a data center on the other side of the world, right? Or if you go to Google and you try to find some foreign language page, right, there's a pretty good chance that it's not locally stored in any United States data center. And of course, security, because you have a bunch of different users, not just one person, you have a bunch of different users, it needs elevated security, right? So for me, I have a device, I have a password. I guess there's ways people could steal my password if they really wanted to, but you know, I don't have to worry too much about that. But cloud, you know, the bad guys are all about going after cloud systems if they can, because then if they do, they have access to the data of millions, maybe billions of accounts. Okay, that would be a very bad thing. Me, you know, I mean, yeah, I guess again, if somebody were really motivated out to get me, probably be worth their time to, hack my system or something. But as far as financially, it's not going to be worth it. Okay, but Facebook, yeah, Facebook's totally worth it. Okay. So the first question is, what is a server? Well, a server is just a computer that delivers requested contents to other connected content to other networked users. So typically the way it's set up, this kind of architecture is going to be between a database system and the users. So typical setup will be like this. You have we'll draw some lines. Okay, so at the top, we have database machines. In the middle, we have a server. And at the bottom, many users. Okay. And there's going to be an interface between them all. So all users for Facebook, they all connect at www.facebook.com. Okay. That's the link that all of these guys go to. Likewise, in the back end, there's also going to be some sort of interface, because when they're getting data to show you, they don't know when you first log on exactly what you're going to want to see, right? And they're not going to have your feed already available, pre-stored as a single file on a database. What happens is when you join Facebook, Facebook looks at, oh, it's you, you're back. Well, let's go gather up what all of your friends and advertisers have been doing. And it looks at all that. And from a variety of different machines, it pulls that data and uses that the server constructs your feed, right? So for each of these machines, they might say, oh, show me stuff that's recent for this account. And then the server constructs that into a feed and sends it to you. Okay, so this is the typical architecture of a cloud, and where the boundary would be is roughly this, right? So everything on this side of the interface, this is the cloud here. Okay. Now, in principle, any networked computer could function as a server. Okay, so last time we were here, turned out that quite a few of you had seen that old movie, The Social Network. There's a bit in there with Justin Timberlake as the guy who founded Napster. Anybody know anything about Napster? Yeah, what you got?
Like a platform where you could share your stuff with, you could share files from your computer.
What kind of files? Yes. Mostly music, yeah. So Napster was basically a worldwide platform for copyright violations, right? If you had some MP4s, MP3s, whatever, you wanted to share them with people, you could register your computer as a server, and then other people could request content from that computer, right? And so there would be some computers would be set up as basically hubs that other computers would connect to, and potentially your computer at any given moment, it could be acting both as a server, delivering data on request, and as a client, pulling data from the Napster system. Okay, so yeah, that's exactly it. Napster broke apart afterward, right? Because again, it was basically a platform for massive worldwide copyright violation. And there were a few people who had libraries in the millions of songs who didn't end up getting some fines, big fines, maybe even some prison time. But obviously, the vast majority of ordinary users weren't prosecuted any more than, people who duplicated CDs to share with their friends or something, right? It's just kind of something that happens. All right. Now, in practice, of course, even though any machine could act as a server, when we talk about servers as dedicated machines, they are machines designed to handle lots and lots and lots of simultaneous connections and running lots and lots and lots of applications simultaneously. So vastly more powerful than a typical client machine, right? Just to give you an idea, you guys ever hear about Elon Musk and moving the servers? You did? What have you heard? What's that? It was a Christmas thing. Well, it's a little crazier than that, but there is a story, right? So Elon Musk moving servers Christmas. Let's see. Elon Musk moving servers himself shows his maniacal blah, blah, blah. Okay, so the deal was they wanted to move a data center, right? And a data center has a lot of server machines. And so they're talking about, oh, there's no way you're doing this in like less than 3 or 6 months. I forget the exact number. And Elon, he's like, no, that's bullshit. You guys are nuts. We could just rent some U-Haul trucks. We could all load them in, right? And if you want, you can read this, right? Maniacal sense of urgency. But the issue, just to give you about servers, this isn't really about Elon. It's about, he says, I've built server centers myself, and I can tell if you could put more servers there. All right, 30 days. Just get a moving company, take a week. All right. Each contained about 5,200 refrigerator-sized racks of 30 computers each. That's the thing to get here, right? So if you want an idea of how big these machines are, okay, each rack has about 30 servers, Each rack weighs about 2,500 pounds, right? So those computers, even if you allow a fair amount of weight for the metal itself, of the rack, say that's half, even if half of that is computer weight, you're still talking like a 40-pound computer for each one. Okay. How much does my laptop weigh? I don't know, maybe 5 pounds, probably not even that. Right. So these are big machines individually, right? That's all. They're big machines. They're probably, an order of magnitude more powerful than, any typical laptop you might have, at least. Okay. So server hardware specialized, blah, 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 blah. Okay. Now, the way cloud systems work is essentially here we have 3 stick figures on the left doing various things, right? These two appear to be doing ordinary web browsing. That's HTML there. This guy must be sending an email. They go to some website, right? Some website that is the interface for the cloud system. Then incoming traffic goes through a firewall, right? So the reason for all this, for the firewall, what it basically says is we've put this website out there to receive data from the outside world, but we want to make sure nothing real bad is coming in either, right? Nobody's trying to hack us. And if we can detect people that are trying to hack us or otherwise mess with our system, firewall can block that, okay? Load balancers, the idea with load balancing is that it looks at each of these is like a rack of servers, right? A cluster of servers. Load balancing is going to say, oh, some new user just joined. Where do I connect this person, right? I could have any of these machines call into the back and access database machines and bring the data they need right away. But I want to, connect them to one that's not super busy, right? I don't want to connect a whole bunch of new users to one cloud instance that's already super busy. So load balancing exists to evaluate that and assign connections to servers based on that. But the only thing users see, right, just like when you go to Facebook, the only thing you see is that you're on Facebook. You don't see which of these back-end machines you're connected to. Okay. Now, what happens on cloud servers is you have a bunch of applications running in parallel. Now, typically, any individual server is going to be set up to run one single application. I mean, you could run many applications on one machine at the same time, but the single biggest reason for that is easier quality of service management. Okay, so example here. All right. Suppose your server cluster has, well, let's say 1,000 users doing Microsoft Excel work, okay? If you add 100 more users also using Excel, how much load will be added? Well, you could probably see that's going to be about 10%, right? You have 1,000 users doing one thing, you have another 100 users using the same application, probably on average representing a similar workload per user. So about 10% more, right? Now, suppose though your server cluster has 1,000 users using Microsoft Word and 1,000 doing live video streaming. Okay. If you add 100 more users, you don't know the probable effect without knowing exactly which applications they use, right? If you add on 100 more users and they're all using Word, it's going to be a rounding error, right? They might download a document, but once the document is done, that's not going to be real busy. If they're doing live video streaming, though, that's a tremendous amount of bandwidth. And if you add 100 users doing that, that's going to be, whatever you have doing video stream. If you have 1,000 there, that's basically going to ramp it up by 10%. So the point is, the more that you mix applications on a server or on a server cluster, the harder it is to know what adding on a bunch more will actually do, right? So you want to avoid that. You don't want to be in the case of saying, oh, I have 1,000 users using Word and another, right, with 1,000 users doing video streaming, and act as if adding 100 more users to one or the other is going to be equally equivalent. It won't. Adding, 1,000 users using Word, that's going to be nothing. Okay. Anyway, so the load balancing always tries to figure out where to assign new connections, basically looking at things of computation requirements, how hard the servers are working, and how much network capacity is going to and from the back end. All right. We'll do this last slide, then we'll call it a day, because this is a good break point, actually. We'll come back and talk about ACID properties on Thursday. Okay, so last thing, thin versus thick. Okay, so the idea is, if you have an application that you're running, the work has to happen somewhere. It could happen on the server. I'll go back to my drawing. Oop. The work could happen here on the server, or it could happen on the client machines, right? So for example, when you go to Facebook, most of the work is happening on a server. The server constructs your Facebook feed, delivers it to you. You might click on something and send that back to the server, and the server sends you new content, but the work mostly isn't happening on your machine. On the other hand, if you're playing some video game, like you're playing Candy Crush or Angry Birds or Call of Duty or something, most of the work is happening locally. Because if every action had to be routed up to Facebook and routed back to you with the proper video frames, it would take forever to go. Okay, so any application you're doing, the work's either happening here or here. Okay, so if the work is happening on a server, then you call that a thin application. Because why? Because not much work is happening on the client. If the work is happening on the client machines, right, your machines, then you call that a thick application. Okay, because that's what they call it. The application is taking up a lot of resources on these machines. All right. The other possibility, right? So thin application versus thick application. The other thing is whether the client machines themselves are powerful or not. So a thick client is a relatively powerful machine. Okay, and these are relative terms. Thin client is a relatively weak machine. Okay, so this brings us to a simple 2x2 matrix of how this is going to work. So your two basic models you might have. You could either have thin application, thick application, thin client, or thick client. Okay. So if your applications are designed to mostly run on the server, right? They're thin applications, it makes sense to not spend a lot of money on client machines, right? So I'm going to put here, work happens on the server, so why spend dollars on expensive client hardware, right? That makes sense. On the other hand, if your applications are thick, they are designed to run on the user machines, once again, this combination makes sense, right? The work happens on the client machines. So the client machines had better be able to handle it, right? So in most cases, if you have thick clients, you have greater ability to run more demanding thick applications, right? Over here, these are the two that are usually bad ideas, right? And here's why. If your applications are mostly running on client machines, you probably don't want weak machines, right? So, this case, thin clients limit how demanding the applications can be, right? It would be like you get the current version of Fortnite, which even with a pretty advanced graphics card can sometimes be a little choppy, and you try to run it on a desktop that's like 5 years old, right? It's just not going to work. So if your applications are thick, you don't want to be stuck with weak hardware. Likewise, if your applications are thin, then it's work happens on the server. So why did you spend all that cash on expensive client hardware, right? Doesn't make sense. If it's a thin application and the work's going to happen on a server, then it could work just as well with some low-end client machine as expensive desktops. All right, so the two models you tend to see a lot in real life, thin application and thin clients. This is probably the more dominant one these days, and thick application and thick clients, which of course that has its place too. All right, but these two, usually a bad combination. All right, this seems like a good break point. Come back on Thursday. We'll talk about acid properties.
Thank you.
Thank you.
I just about the lab.
Okay.
So, I mean, I went there, but I was kind of late, so I couldn't understand what this was. I mean, should I send an email to the TA?
You could. I mean, it depends on what the question is. What's the question?